Good day, everyone. Welcome back to our class. We are still on LED blinking. So today we'll be looking at how we can use a command called for loop to on and off our LED in different mode. And the name of this class will be SOS signal pattern. In our previous class, I talked about how to comment out line of code that we are not making use of, and I said we have two ways of commenting line of code, which is single line commenting and multiple lines commenting. So this is just an example of how to comment out multiple line of code. This first line of code is just to initialize the LED pin at which we want to attach our LED to pin 8. Inside our setup, we also initialize our LED pin to be an output. Now, this is where the bone of contention is. Now, the for loop, which is this, three statements. Number one, you have to initialize your variable. Number two, you have to give it a command, that is a statement that is going to follow. And number three, you have to increase. It's either an increase or you decrease the variable. Now, as for this for loop, what we wanted to do here is, we said for int x is equal to 0. This int simply means this x is an integer, and we say initially x is equal to 0. You put semicolon, meaning this statement has end. Now the next statement, now we said x is less than 3. Now how it works is this: initially x is equal to 0. Once x is equal to 0, the compiler will come to the next line here, which is x is less than 3. So it's going to check, is x less than 3? This simply means yes, since x is 0 initially. So it will now compile this code here. It will compile this code which says digital write LED pin I, meaning it's going to on the LED for 150 milliseconds. After that, it will off it for 100 milliseconds. Then this line of this command, this statement now will now come in place. So it will now increase this x by 1. So meaning x is equal to 1. Now this line of code, this x less than 3, we now check, is x less than 3? Yes, x is less than 3. Since x is 1, now it will compile this code. Then x will increase by 1 again. Now x is now 2. Once x is 2, so this x is equal to 0 will now be x is equal to 2. So this line of code, this command will now check, is x less than 3? Yes, it's still less than 3. These four lines now, they will compile again. So this x, after this compilation, this x plus plus will now increase again. X now will now become 3. So in this x is equal to 0 now, x is now 3. So this code will now check, is x less than 3? No. Now x is not less than 3. So after that, it will just leave this for loop and come to this second for loop and does the same thing that it did for this for loop. The difference between these loops are just the delay. So after this for loop, after they have compiled, it will delay for just 1 second and go back again, and it will repeat this for loop. So that is how it's going to until you stop the simulation. So let's quickly go to Proteus to simulate what we just said and see how it works. Proteus, don't forget you have to run as administrator. Click on new project. After that, rename SOS, then browse for our folder is on desktop. So embedded system, then that's our simulation. So open another folder here, name it SOS, then select file and next, 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 then finish. Simulate your work. Pick your Arduino Uno as we've done earlier, connect it to pin 8, then your resistor should be 220 ohms, then your LED too should be an active LED. Then go back to your code, let's save it. Click on file, save as, go to desktop, just navigate your folder, then so my class code. So here I want to name it as SOX. Then another thing you need to take note of here is that in the simulation folder we create a new folder, but in class code, in Arduino folder, you don't need to create any folder. It's going to create its folder automatically. So yours is just to give it a file name and save. So once you save, it's going to create a folder by itself. Then you compile, which is verify. Our X part, highlight on the S part, then you copy, which is Ctrl C. Go back to your simulation, then you paste, which is Ctrl V, then OK. You can now run it. You can see that there is difference between the first blinking, the second blinking, and also the third blinking. So you can alter the delay. You can see the effect of those delays. So this is part of our LED blinking class. Let's try ours and submit in the submission group. So see you in the next class. Bye for now.